March the 29th through April the 2nd, lesson 25, incredibly useful ratios. So we've been talking about right triangles and talking about the Pythagorean theorem and some, we wrote some ratios the last time. We want to look at what these incredible useful ratios are going to be. Alright, so let's go ahead and look at exercises 1 through 3. It says, use the right triangle ABC to answer questions 1 through 3. Name the side of the triangle opposite of angle A. So the side opposite angle A would be side CB, or side BC, however you want to name it. Alright. Name the side opposite the angle B. So the side opposite angle B would be side AC. Alright? Name the side of the triangle opposite angle C. That would be side AB. Alright? Another common way of labeling the sides of a triangle is to make use of the relationship between the vertex and the side opposite. And so we could use lowercase letters. So the side opposite of angle A would be lowercase a. The side opposite of angle B would be lowercase b. And the side opposite of C would be lowercase c. Alright, it is the lowercase of each vertex. Now we're going to discuss another set of labels. These labels are specific to right triangles. So once again, like I said, these are specific to right triangles. The triangle, let me draw you a triangle here because we're going to talk about some triangles. Alright, so let's look at this triangle. Alright, I'm going to name this triangle ACB. So the triangle is a right triangle. It is triangle ABC. We're going to denote the angle B as the right angle. Alright. Of the two acute angles, we're going to focus our attention on labeling angle A. So we're going to mark angle A in the triangle with a single arc. Alright. With respect to the acute angle A of a right triangle ABC, we identify the opposite side, the adjacent side, and the hypotenuse as follows. Alright, so when I'm talking about angle A, alright, this is all in respect with angle A. The opposite side of this would be side BC. Alright, so we're going to call this the opposite side. Alright, once again, this is all in reference to angle A. With respect to angle A, the adjacent side is going to be side AB. Alright, so the way that you can remember this, the side opposite is the one that is straight across from that angle that you're looking at. So I'm looking at angle A, so the side straight across from angle A is side BC. The side adjacent to the angle is the side that kind of shares that angle. Alright, so angle A would have the opposite, or the adjacent side of AB. The hypotenuse is the same as always the hypotenuse. The hypotenuse is the side that is straight across from the right angle. Alright? Hypotenuse is straight across from the right angle. That is side AC and is opposite from the 90-degree angle. Alright? So, this is what we have. Now, I abbreviate these like this. Alright? We abbreviate our sides like that. All right. The sides are identified with respect to angle A, or using angle A as a reference point. The labels will change if we are looking at an acute angle, if we're looking at another acute angle. So if I were to look at this, let's say that I want to look at my same triangle here. All right. With B being my right angle. My angles will change if I'm looking in reference to angle C. Alright, my hypotenuse stays the same because it is the side across from the right angle, but now my opposite and my adjacent will change. So the side opposite of angle C is side AB, and the side adjacent to angle C is side CB. So these will change depending on what acute angle you are looking at. All right? It all depends on the angle you are looking at. All right, so with that being said, for each exercise, label the appropriate side as adjacent, opposite, and hypotenuse with respect to the marked acute angle. All right, so they have marked our acute angles with the arc. So here I am looking in reference to angle F. Once again, my hypotenuse is not going to change. The hypotenuse is straight across from the right angle. So we will label that the hypotenuse. And you can use the 3-letter abbreviations. All right. Now I'm going to look at the side opposite of angle F. Is the side straight across from angle F. So opposite. And then the side adjacent to angle F is the side that kind of helps form that angle. All right? Let's look at number 5. Number 5, we've got in reference to the angle R. Hypotenuse, straight across from that right angle. So here's my hypotenuse. The side opposite of angle R is QP. And the side that is adjacent to angle R, or that side that helps form angle R, is QR. All right? Let's look at number 6. All right, number 6, I'm looking at reference to angle K. Hypotenuse straight across from that right angle. So the hypotenuse would be JK. My opposite would be straight across from K. And my adjacent would be the side that helps form K, so that would be KL. All right? All right. So, give me just a second, guys. I got some pop-ups on my camera here. Hopefully that'll take care of it. All right. So, now that we've done that, we now know how to label the sides depending on what angle we're looking at. All right, so in the following exploratory challenge, we're going to be looking at different things. All right, we're going to be looking at angle measures. We're going to be looking at these different triangles. All right, so it says the angle measures are approximations. All right, that means they're not exact. For each triangle in your set, determine missing angle measurements and side lengths. Side lengths should be measured to 1 decimal place. Make sure that each of the adjacent over hypotenuse and opposite over hypotenuse ratios are set up and missing values are calculated to 1 decimal place. All right, so let's look at this. So I have triangle ABC. We want to know what the angle measures are. We want to know what the length measures are. And then we're going to look. They've given us the hypotenuse, or the opposite over hypotenuse, and they've given us the adjacent over hypotenuse. All right? So, let's talk about how we can figure this out. All right. So, I know that I have triangle ABC. All right? let's see. I'm given my opposite over hypotenuse, and I'm given my adjacent over hypotenuse. All right? So we can kind of draw this out. All right? And I can think about this. Now, I've got to think about how I'm going to label this, so give us just a minute here. All right? So I know that my hypotenuse is 13, so I know this is 13. All right? And I know that this is a right angle. All right? And I know that my opposite, now this is where it's going to be a little tricky. So how are we looking at this? All right? My opposite, let's just go ahead and we'll label this A, B, C. All right? So I'm going to do in reference to angle A. All right? So I'm going to look in reference to angle A. So angle A means my opposite would be 12, and my adjacent would be 5. All right? So that gives us our length measures. So AB is equal to 5, BC is equal to 12, and AC is equal to 13. All right? Now, how would I get my angle measure? All right? So let's think about this. How would I get my angle measure? Well, I know that I have a 90-degree angle here. When we have a right triangle, well, first of all, we know that the three measures of a triangle, the three angles of a triangle, equal 180 degrees. Sorry, guys, I completely lost my train of thought here. All right. So what I can do is, in order to find my angle, I can do a couple of different things. I know that I have to split 45 degrees, 90 degrees between my two angles. All right? So I want you to think for just a second, and I want you to think, how might we be able to do this? How might we be able to figure out the measure of this angle? Pause the video, take a moment, and see if you can figure this out. Because I really hate to, I don't want to give you the answer immediately. I really would like for you to try this out. All right. Triangle ABC, the measure of angle A is 67 degrees. All right? We will come back to how we figure this out in just a little bit. All right? We'll talk about how to do that. Let's look at triangle DEF. This time they give us the measure of an angle, and then they give us our side lengths. Okay? So, we have triangle DEF. So it says that DE is 3, EF is 4, and DF is 5. And we are looking at in reference to angle D, because that's the angle it gives us. All right? So I want to do opposite. So that would be 4 over hypotenuse, which would be 5, and I'm going to divide that out. That gives me 8/10 because it says calculate to 1 decimal place. Alright, then I've got adjacent. So angle D, my adjacent is 3 over hypotenuse, which is 5, and that divides out to 6/10. Alright? Alright. Let's go ahead and look at our next one. They've already given us most everything. Alright. They haven't given us all of everything, but they've given us quite a bit. So I've got triangle GHI. We're looking at in reference to angle I. It says GH is 5.3. Alright. So here it tells me that my opposite divided by my hypotenuse is equal to 0.66. So what I can do here to figure out my x is I can multiply I can set this up as like a ratio, and so I'd have 0.66x is equal to 5.3. So I'm going to divide 5.3 by 0.66, and that gives me approximately 8. Alright, it says to round to the nearest. So now I know my hypotenuse is 8. Alright, now I've got to figure out my adjacent. Well, here I know that my hypotenuse is 8. Alright, which means once again, so I can set it up as a ratio, x over 8 is equal to 75/100 over 1. So now here I would multiply 75/100 times 8, and that would give me 6. Alright, so now I'm going to go ahead and fill in this part here. So I know that GH is 5.3. I know that HI is equal to 6. And I know that GI is equal to 8. Alright? Alright, let's look at triangle JKL. Alright? And I think, yeah, this is where I kind of screwed up. I was supposed to give you guys triangles, and so really you couldn't do the angle measures because you don't have protractors, but that's okay. It's no big deal. Alright, so triangle JKL, and you'll see, I'll give it to you. You'll get a sheet that looks like this. Alright, you'll get a sheet that looks like this that you can use to mark on. And then it tells you what reference angle we're looking at. That was my bad, guys. I'll make sure you have those when you get your packets. Alright, so number 4, angle JK or triangle JKL, we're looking at reference to measure of angle L. And if you measure that, you get 30 degrees. Alright, so I'm just going to keep drawing over here. So we've got JKL. Alright. We're looking in reference to angle L. It says KL is 6.93 and JL is 8. So we've got the opposite. I don't know what the opposite is, so x is equal to, or x over 8 is equal to, what I suggest you do here, let's see, let me make sure I drew my triangle correctly. Sorry guys, It's been a very long day and it's only like 10 o'clock. Number 4, JKL. JKL. Okay, so they've got L up here and they've got K down here. So we're looking at that one. And it tells me that KL is 6.93 and that JL let's look at this. Alright, so I've got JKL. I know that KL is 6.93. I know that JL is 8. So it wants to know opposite over hypotenuse is equal to something. Really, I don't know that you can do this one without this, so I'm going to give you this part. That's why I was looking at it, because I think they forgot to put something in there. So how would I figure this out? So I would multiply 8 times a half, which would be 4. So that tells me that my opposite, JK, is 4 centimeters. Alright, then I've got my adjacent over my hypotenuse. Well, we already know what the adjacent is. The adjacent is 6.93. Alright, let's look at number 5. Triangle MNO. We're looking at the measure of angle M is equal to 28 degrees. Alright, now we can look at this. We can look at our triangle and base that off of, so I know my hypotenuse, I know my adjacent, and I know my opposite. So I know that MN is equal to 7.5 centimeters. I know, excuse me, that NO is equal to 4 centimeters. And I know that OM is equal to 8.5 centimeters. Alright, and then we finished everything there. Alright, so here's what I'd like for you to do. I'm going to give you some of this, and then I want you to finish this for homework. Alright, I'd like for you to finish this for homework. I'm going to go ahead and give you the measure of the angles that you're dealing with. So make sure you copy this down. Alright, the measure of angle D, the measure of angle I, the measure of angle L prime is 30 degrees, and the measure of angle M prime is equal to 28 degrees, okay? Alright, so finish this, and then come back and we'll do the rest of the lesson. Alright? So for each question, approximate the unknown lengths to 1 decimal place. Refer back to your completed chart from the exploratory challenge. Each indicated acute angle is the same approximate acute angle measure as in the chart. Set up and label the appropriate length ratios using the terms opposite, adjacent, and hypotenuse in the setup of each ratio. Alright, so let's look at this. So, I have this triangle. My acute angle is 53. Alright, so I want to do, I got to figure out my 2 lengths here. Alright, so I'm going to do opposite over hypotenuse. Alright, and it says that the angle that was 53 degrees, my opposite over hypotenuse was 8/10. So I'm going to set that up as equal to 8/10. Alright. So my opposite of this angle is y over the hypotenuse is 7 is equal to 8/10. I would solve this by doing a ratio. So I would multiply 8/10 times 7, which gives me y is equal to 5 6/10. Alright. Then I'm going to come over here and I'm going to do my adjacent over hypotenuse. Alright, and then so the 53-degree angle, the adjacent over the hypotenuse was 6/10. Alright. So we're going to do adjacent, which is x, over hypotenuse is 7. Alright, multiply that, 7 times 6/10, and gives us the x is equal to 4.2. Alright, number 8. Number 8, I'm looking at the measure of the 30-degree angle. So the opposite over hypotenuse of the 30-degree angle was 5/10. Alright, so we're going to set this up. So I'm going to look at the opposite, which is 9 2/10, over my hypotenuse, which is z, is equal to 5/10. Alright, in this case I get 5/10 z is equal to 9 2/10. So I'm going to divide 9 2/10 by 5/10, and that gives me 18.4. Alright, now I've got my adjacent over hypotenuse. Going back to that 30-degree angle, that is equal to 0.87. Alright, let's set that up. My adjacent is x over hypotenuse, which we now know is 18.4 is equal to 0.87. Alright, cross multiply, so x times 1 is x. So I would multiply 18 4/10 times 87/100, and that gives me that x is equal to 16. Alright, and the number 9, opposite over hypotenuse of a 67-degree angle was 92/100. Alright, so then let's look. My opposite is 21 6/10 over my hypotenuse is z is equal to 92/100. Z times 92/100, and then 21 times 1. So I'm going to divide 21.6 by 92/100, and that gives me 23.48. Alright, and then my adjacent over my hypotenuse. So we're dealing with the 67-degree angle again, so it's 38/100. Alright, so I have my adjacent. So the adjacent is x, which I don't know yet, over my hypotenuse, which I know now as 23 4/800. Is equal to 38/100. So I'm going to multiply 23 4/800 times 38/100, which gives me x is equal to 8.92. Alright? Alright, last question. From a point 120 meters away from the building, Serena measures the angle between the ground and the top of a building and finds it to measure 41 degrees. What is the height of the building round to the nearest meter? So let's think about this. We're trying to find y. Let's label, so this is our hypotenuse, this is our adjacent, and this is our opposite. Okay? According to, we're dealing with this angle. Alright? So, I can set up, I'm trying to find my opposite. So I can set up the opposite hypotenuse. We already know, since I'm trying to find my opposite, I'm going to use my opposite over hypotenuse. Now we already know of a 41-degree angle that the opposite over hypotenuse is approximately 66 hundredths. Alright? So, let's go ahead and look at this. Opposite is y over hypotenuse. I don't know what that is. So, I'm going to have to figure this out. I've got to do, since I know my adjacent, my hypotenuse, I've got to find my hypotenuse. Alright, so the adjacent over the hypotenuse of a 41-degree angle is 75 hundredths. Alright, so the adjacent is 120 over x is equal to 75 hundredths. I'm going to divide 120 by 75 hundredths, and that gives me that my hypotenuse is 160. So now I can come over here and say, okay, my hypotenuse is 160. So I'm going to multiply 160 times 66 hundredths. So y is equal to 105.6. So the height of the building is approximately 106 meters. Alright, so approximately 106 meters. Alright guys, this was kind of a long lesson, but hopefully you learned something.